welcome back to Jeff Geo Academy YouTube channel. So, we are discussing about the Igneous Petrology. So, this is Igneous Petrology lecture 4. तो चलिए शुरू करते हैं. So, today our topic is magma viscosity. So, first of all, we have to understand the Newtonian fluid because most magmas are Newtonian fluid. Okay, so now what is a Newtonian fluid? So Newtonian fluid must obey the Newton's basic law of mechanics, which means it will respond to a shear. You know the shear tau by flowing at a rate which is directly proportional to it. That means du by dy, du upon dy is the shear rate, and the constant of proportionality is called the viscosity. So tau will be equal to eta du upon dy. This is the formula, and now eta will be equal to tau divided by du upon dy. So most magmas are Newtonian fluid, and Newtonian fluid means what? Fluids such as water having a constant viscosity, which have constant viscosity fluid, then we call that Newtonian fluid. Now another term is shear thickening. So viscosity increases with the rate of shear thickening. Another term is shear thickening. So shear thickening means viscosity eta will be increased with the rate of shear. As the shear increases, shear means du upon dy. When du upon dy, which is shear, increases, the viscosity also increases, and that what we call shear thickening. Okay, thinning. So eta, the viscosity decreases with the rate of shear. The viscosity must decreases with the rate of shear. And now another important term is Bingham Plastic. Bingham Plastic is that material that behaves as a solid at low stresses but flows as a viscous fluid at high stresses. Okay, so Bingham fluid is that fluid that behaves as a solid at low stress rate but flows as a viscous fluid at high stress rate. You know the most magma having crystals. So now here I have illustrated this diagram. This is block 2, this is block 1, and the spacing between the two blocks is y. Suppose F forces we are applying in this direction, and the viscosity suppose is u. So you know the force applied will be directly proportional to u a upon y. Now F will be equal to eta u a by y, and here eta is the viscosity constant. You know this is a coefficient of viscosity, and now F will be equal to eta u a upon y. Now differentiate both sides. F df by dA will be equal to eta, since it is constant. Eta will be here, and now du upon dy. Now tau will be equal to, since df by dA is the tau, will be equal to the stress, will be equal to force per unit area is the stress, will be equal to eta du upon dy. Now the fluid must follow this law. Tau will be equal to eta du upon dy. A fluid must follow this law, this formula, to be a Newtonian fluid. Okay. Now see the illustration here. In the x-axis I have taken the stress du upon dy, and this is tau. Okay, so the graph, this is slightly increasing in this direction. So this is a non-Newtonian fluid, and this is a gradually increasing. When tau increases, du also increases. So this is Newtonian fluid, and this is again non-Newtonian fluid. It is slightly increasing, and this one increasing in the x and y direction. This is Bingham Plastic. Okay. So now what are the factors that affect the viscosity? We will learn this. Here viscosity is the resisting force that does not allow the magma to flow and related to stress, because eta coefficient of viscosity will be equal to tau divided by du upon dy, and its unit is in Pascal second, parsec. Okay. Now, what are the factors that will affect this viscosity? So, first factor is the temperature. The viscosity of lava falls exponentially as temperature increases. So, this graph in this x-axis, I have taken the temperature in degree Celsius, and in the y direction I have taken the viscosity in Pascal second. So, look, the viscosity is decreasing from 10 to the power 4 to it is going to 10 to the power 10, from 600, 800, 1000, 1200 and 1400. The viscosity is decreasing exponentially, and for alkali basalt it is also decreasing from 10 to the power 2, from 10 to the power 2 at 600, 10 at 1000, and 10 to the power yeah. So it is decreasing the viscosity is decreasing exponentially. Now, second important factor is the SiO2 content. SiO2 content. So the viscosity of lava increases as the SiO2 content increases. So SiO2 content will be directly proportional to the viscosity. Because as SiO2 content increases, it will increase the polymerization, increasing polymers will form, polymerization, and when the polymerization will increase, it will increase the viscosity. So SiO2 content will be directly proportional to the viscosity. As SiO2 content in the magma or lava increases, then the viscosity of magma also increases. Now, third important factor is the effect of water solubility on the viscosity. So, water attacks and breaks up the structure. Of silicate melt, which leads to a decrease in the extent of polymerization. The extent of polymers formed will decrease in the structure, and this makes the flow easier, which makes the flow of water easier. Which makes the flow of magma will easier. That means water breaks up the enter in the structure, and it will break the silicate melt. It will decrease in the extent of polymerization and of the structure, and this will make the flow of magma or lava easier. Look, one example here. At a given temperature, the viscosity of rhyolite with 28% dissolved water is 100 to 1000 times lower than that of dry rhyolite. That means if the viscosity of dry rhyolite, if the viscosity is 1000, with 28% rhyolite, with 2 weight% dissolved water, the viscosity of rhyolite is 1000, then its viscosity, the viscosity of dry rhyolite will be equal to only 1. Okay, so we can conclude that the solubility of water is inversely proportional to the viscosity. That means when the solubility increases, the viscosity will decrease. When the solubility of water decrease, the viscosity will increase. Okay. Now, fourth important factor that will affect the viscosity of magma is the effect of crystal on viscosity. So, the viscosity increases with crystal content in a non-linear way. Look this illustration. This is the crystal content in the x-axis, and this is the viscosity, coefficient of viscosity in the y direction, and the viscosity increases in a non-linear manner this way. Okay. In this manner, the viscosity will increase. Okay. Now, melting, the thermodynamics view. So we are dealing here the Gibbs free energy. So the Gibbs free energy G will be equal to H enthalpy minus temperature into entropy. So here G is the Gibbs free energy, H is the enthalpy. Now what is enthalpy? The total energy contained in a system is the enthalpy of the system, and T is the temperature, and S is the entropy. Now what is entropy? Is the degree of disorderedness of the system. So the TS amount of energy will be used up due to the molecular vibration and by subtracting Ts, which is energy used up by molecular vibration, from the enthalpy will give us the free energy, which is free. The amount of energy remain in the system is the gives free energy. Okay, so remember the formula. No one is going to ask to derive the formula, so I am not going into that. So now this is the we are concluding here. This is the end of the lecture. In the next lecture we are going to discuss latent heat, crystallization of magma. Okay, remember crystallization of magma is not same as the melting. Okay, so you are not giving me the answer of quiz, so I am not giving the quiz questions. So stay tuned with the channel. Thank you for your patience.